This CSI question is a two-step question, isn't it? It's 2 steps.
Do you use the same formula both times?
No. Is there any horizontal acceleration? 5? Oh. Are you ready to see?
Yeah.
First step is find the time of fall. D equals VIT plus a half AT squared. What is the vertical displacement in the CSI question? Minus 43. What is the initial velocity falling? 0. Plus 1/2 of minus 9.8, because 9.8 is the vertical acceleration, and you're solving for t. (43 divided by 9.8). 4.4. Oh, that's square root.
You wouldn't divide by 9.8, you divide by 4.9.
Oh, yeah. 2.96, right? 2.96 seconds? Yes? Okay. Same formula as before. Listen, you guys. Listen. Same formula as before. But now, instead of knowing this one, what do I know? I know this one. All you got to do is take that distance, which is 18, divided by the time. That's all there is to it. 6 meters per second. Six meters per second. Now, did the person drive off the cliff at 6 meters per second?
Why did you use highway speeds? You only gave us 2 options, but you could use highway speeds or push off.
Well, because you know what, like the CSI guys, they don't have, all they have is what's there, right? It's not, there's never going to be an action in the bag. They have to use their brain. 6 meters per second times 3.6. The car was going.
1.6.
Yeah, 21. I got 21.9.
Nothing but 3.6.
Because the question is, was the car driving at highway speed?
Yeah.
Do you know how fast people drive on the highway in meters per second?
No.
I'm a nerd and I don't know that.
Then how would you know what to talk about?
Because what do you know the magic number to convert meters per second to kilometers per hour, don't you?
Yeah, 21.9.
To convert, Hannah, from meters per second to kilometers per hour, you know to multiply by 3.6. And so this vehicle was traveling at about 22 kilometers an hour when it went off the cliff. Was it driving at highway speed?
Was he pushed off?
No. We'll never know. What would be your guess? What would be your guess?
He was slowing down. He was driving over like
Maybe the car was slowing
There was a
down.
little bit of an incline, but the push.
Could be. Maybe someone used their put the car in drive, right? And then gave it a, because when you put the car in drive, what does it do? Starts to drive by itself. Do you think it might be traveling at about 20 kilometers an hour, driving by itself, with no foot on the gas pedal? Maybe it needed a little nudge, right? The vehicle was certainly not driving at 100 when it went off the cliff. I hate to tell you this, but that's a straightforward, simple. The only difference is what? What's the only thing that I changed, Steve?
We're not looking for range.
You're not looking for range, you're looking for speed, right? That's the only thing I changed. Concept's the same though.
Concept's the same, just backwards.
Just backwards. Okay.
Alright, got another question?
Oh.
Sounds like I'm now.
Okay, let's do sample questions number 2. Up to now, you've done sample questions like this, right? You've done off the cliff, you just did that, drive off the cliff. You've done projected off the cliff. This is type 2 on a flat surface, like a guy throwing a runner out at second base. Back in the good old days when I was young and had an arm. Those were the good old days. With our handmade baseball and our... I did. Okay. Hey, let's get the clickers out.
Ryan's gonna get me a
Here's a sample question to help guide your thinking. Save this. Use this for practicing your questions. If you haven't started practicing problems, you need to. Don't leave it till the test day. What, Chris? No. You're going to find it out, right? Or I'm going to ask you right away, I think. A ball is hit at an angle of 30 degrees and leaves the bat with a velocity of 40 meters per second. What brand of bat is it?
Louisville Slugger.
Easton.
There's the metal ones though. They wouldn't go that fast.
Oh no? 40 meters per second is pretty fast, isn't it? How would you figure that out in kilometers per hour?
That's how fast they were throwing it.
Does it?
Might not be that fast.
Might not. Maybe it's a neck player.
Are they digging? They might feel.
I want you to tell me what is the vertical velocity, the vertical component. How do you do it? Break it into components. You can do this. We've done this already. Whoopsie. How do you find the vertical component? We did it yesterday too.
Let's just type it in.
Yeah, just type it in. 1 decimal place, I believe. How do you find vertical component?
Do it.
Use the sign. How come? Sign is opposite. Opposite 30. What's your answer?
We'll just put it in here.
Yep.
Oh, well, I just finished it, you just did it.
I'm trying to speed things up because I got to get done.
Yeah, but
Does that make sense to you?
Yes. It does make sense.
Too slow. 20. Chance for redemption. What do you think the next question's going to be?
Same thing, horizontal.
Oh! Find the horizontal component. 1 decimal place.
round or
Round. Always round.
what's the safe number to round? Because sometimes you do
1
1
decimal
or you
place.
do 2, and then sometimes my answers are almost wrong because of 1 and 2.
1 decimal place. Pretty sure.
You can do 2 a lot.
Rounding. Truncating is the other one, and it's bad.
Okay, I like it. That's the always pick the lovely one, right?
That's what you just cut it off.
Okay, truncators.
I was just wondering.
I wasn't building anyone's abilities. 24.9. 24. 24.
Or so if I like you combine both. Like if it's around like your 4, 5, 6s, it doesn't really matter. You just kind of.
Yeah, yeah.
But I mean, as soon as you put your sevens.
Oh, I see. So it's judicial rounding.
Or your ones or your twos.
Relative rounding.
Yeah, I don't like when you
Yeah.
got threes are kind of like if you look over
Makes
the
sense.
that's what Mr. Ray calls.
Mhm.
I've been, okay. Do we even do?
Oh, I got it.
That's a good deal.
Yeah, I didn't know how to do.
Oh, am I the green card?
I didn't know how to do the decimal signs.
There's a little decimal point at the bottom.
Yeah, but I pressed it and then it didn't.
Oh yeah? You gotta press the next number, the next digit, I think.
Oh, I made it wrong.
Okay, now, so we've broken it down into components, right? That's gonna always be step one. Mr. Bennett, how come you didn't break it into components on the CSI guys driving off the cliff? Because I already gave it to you in components, right? You only need to break it into components when it's projected at an angle. If it's not at an angle, you know the horizontal and vertical. Okay, how do we find the time of rise? Remember, it's going up like this and coming down. Which, we're going to use VF equals VI plus AT. Which V do I use for VI? Do I use 40, 34.6, 20, or minus 9.8? A, B, C, or D? It's multiple choice. Which V do you use in this place right here for VI? What is the VF, by the way?
0.
Why?
At the end, it could be.
Time of rise. How fast is it going vertically at the peak?
Are we answering
VF, you're answering A, B, C, or D. The question is, which V do we use for VI? That is the question you are answering. Which V? We've got 3 so far. We've got 40. We got 20. We got 34.6. Which V do you use for VI?
Oh, okay.
Please, everyone. Oh. Why do we use 20? Because that's the vertical component. Now you got to put that away. That's part of the problem.
Not part of the problem, I just forgot it for a second and I answered the question right, so.
Use 20 for VI. Not the horizontal. It's going up. So how do I find the time of rise? VF equals VI plus AT. 0 is your final because it's going 0 vertically at the top. VI is 20. Minus 9.8 is my acceleration. Solve for time. 2.04 seconds up. I would if I was you. I'm doing a sample here. What do you think the next question's going to be?
Total time.
It might be. What would be the total time, right? Ah, maybe don't say that yet. No.
7.
6. Yeah, it would actually be 4. Let's get around.
Oh, yeah. 7 rounds.
Apparently, the question is the height of rise. How high does it go? I don't see a clicker thing here. You just got to figure it out.
Little, you can see like the writing.
Yeah, the fine print. Now you know how Grandpa feels when he's trying to read the pill bottle. Height of rise. What do we know? What are we solving for? D. What do I know? I know the time of rise. I know the vertical acceleration. I know the initial velocity. I know the final velocity. I know everything about up except the height. So I could go like this. VF is 0. That's what it is at the peak. VI is 20. 2 AD. Solve for D. The baseball goes up 24.4 meters. It's a maximum height of 20.4 meters. I have a big oar here, and there's nothing to do with the boat. What's the other formula to use? What would be the other way? VIT plus a half AT squared? Should it give you the same number? Sure should. Is that the one you would use, Zach?
Probably.
Yeah? Because it's like D equals, right?
Because I always use that one for everything else.
Okay.
I never think of the other one.
Hey, Rexing on.
Same answer. What do you know?
20.4. 0.41. But I've rounded down to 20. Oh wait, I didn't have to do it. How do you do it? What do you do?
Now,
I think just.
do you sense something coming about? Ryan was right earlier.
Range.
I'm going to ask you how far it's going, aren't I? But before I can ask you how far it goes, I have to ask you. Well, let's just see if the time of fall, is the time of fall going to be the same as the time up? Is the distance up the same as the distance down?
Yeah.
Distance is the acceleration up is the same as the acceleration down?
Yeah.
Acceleration? Yeah.
It's on a horizontal surface.
So let's just see here. D minus 20, how come? Falling. Initial velocity in the fall interval is 0. The initial vertical velocity is 0. Plus 1/2 AT squared. What do you know exactly the same time? Shot.
So we don't really have to do this.
I'm just proving it to you. Will that always be the case? Will the time up always be the time down?
Only on a flat surface.
Exactly. That is only true when it's a flat surface.
Wasn't it the same, the vertical velocity or whatever, it was 20, where'd that go? Why is it 0?
Because now it's the initial, it's the, on the up, this is the VI is 20 and the VF is 0, right? But on the way down, the VI is 0 and the VF, what would be the vertical component when it hits the ground? 20. Exactly.
We should do like a class field trip day, like a golf course.
Yeah?
It's free now.
I heard something about that. I gotta figure out what's going on out there.
18 and under.
18 and under or under 18?
18 and under. It's free golf. Well,
I gotta find some more about that. Maybe in the paper
it's in the
today.
paper.
In the paper today, maybe?
No, in the paper like a week ago.
Oh yeah, I missed it. Okay, what will be the time of flight? I want to show you 2 crazy ways.
Oh, but I didn't finish it.
You didn't finish it? Oh, I'm sorry. Okay.
No.
Now, the time of flight. We already know this, right? Time up 2.04, time down 2.04. I had to figure that out 2 different ways, right? Would you agree with me that the vertical displacement for the entire trip is 0?
Yeah.
Vertical displacement. So if I put 0, we kind of did this yesterday. If I put 0 in there, what's my initial vertical component? Positive 20 up. Positive 20 plus 1/2 minus 9.8. What do I end up with here? 4.9 t squared minus 20t is equal to 0.
Factor out a t.
Now, I could use the quadratic formula, and it would be ugly. It would look like this. And what do you know? And you don't have to write this down, just watch. You would get 4.08. Is this kind of what we did yesterday?
Yep.
It's exactly what we did yesterday, except we didn't have displacement of 0 yesterday. We had displacement of whatever the height of the cliff was.
Yeah.
And it was ugly, and you had to use the quadratic formula. But as Steve wisely pointed out, we can take this thing right here, this 4.9 t squared, and do what, Steve?
Take out t.
Take out a t. Remember doing this in math class? You do it all the time?
Yeah.
And so this tells me that either t is equal to 0, Or 4.9t minus 20 is equal to 0. And t is 20 over 4.9, which is?
4.08.
Why are there two answers?
Because there's two ends to the point.
There's two times when the vertical displacement is 0. What are those two times? Well, when it's at the end, 4.08, and also at the start, when it hasn't gone anywhere.
Why are you doing all that crap when you could have just added them?
We can.
But
The reason that I usually do this, and people get all confused, is because, remember, I inadvertently did sample 3 yesterday, did them out of order because I thought I'd done this one already, because I want to show you this elegant method tomorrow, which was yesterday. Remember how we did that yesterday? We put a negative D. Can you remember doing that? Yeah. So this is the same stuff. The only difference is that you can't do this factoring, can you? Because there's a C, yes. There's a C.
which one should I be writing? The one that
Any one you want, Hannah.
But is there one that we want to write?
No, they're all, it's about understanding is what it's about. You can print this out later if you want to. You don't have to write it down. I want you to know two things. The time up is equal to the time down when it's flat. And when it's flat, also the vertical displacement is 0. Those are the two things I really want you to know. I'm also going to ask you, how far does this object go? What two things do I need to know to find what is the range? It's actually the horizontal displacement. Is there acceleration horizontally? No. So do we need an A in our formula? No. Which velocity am I using? How did I get that? Go way back to the start.
Bring it on back. Yeah.
Horizontal velocity,
Oh, right.
right? So how are we going to do it? Yeah. Straightforward, right? V equals d over t. Why no acceleration? Why no A? There's no horizontal acceleration. 0. This object is traveling 141.17 meters. That's its range. Okay. There is actually one last question. What could it possibly be?
Are you kidding? I'm not gonna prove.
Just watch. Just watch. You don't have to write down, you guys. You guys, you're so... Just watch and learn. What's the velocity of impact? It's the vector sum of VH and VV. Will the final velocity be different from the original launch velocity?
I got a question for you. Does it matter if you put VV first or VH first?
In the squared thingy?
The triangle.
No? There's no air resistance in this world. Will the final velocity be different from the original launch velocity? What was the original launch velocity? 40, I think, right?
Yep.
Will the final impact velocity, will the speed that the golf ball is traveling when it hits the ground will be the same as when it leaves T's golf club at the tee?
Yes. That's the there.
Does the horizontal velocity change?
No.
No. Does the vertical velocity change? Yes. It goes up to 0 and then it comes back down. Does it travel the same distance up and down?
No. Depends on what it was.
Yes. Whenever it goes up must come down. Is that time the same? Is the acceleration the same? So the speed at the bottom, the vertical part, should it be the same as the speed going up? Just different direction? Yep, which means what? The whole thing is going to be...
Oh, wait.
Oh, what do I do? Oh, mother.
Answer yes or no.
Oh, okay.
Will the final velocity be different from the original launch velocity?
No. Is that right? Oh.
How come? Watch. Like I just said,
Why is it already done?
The horizontal velocity is 34.6, right? The VV is the VF for a falling object for 4.08 seconds. Hold on, Mr. Bennett. It's not falling for 4.08.
No, it's not.
Well, it is. It's actually accelerating for 4.08. It's just starting off positive, right? So if I were to do this, if I were to give it an initial launch velocity of plus 20, and I accelerated at minus 9.8 for 4.08 seconds, what does it come out at? A little bit of rounding, minus 20. So it's going just as fast down as it's going up to start, which means what at the end? Yep. Steve was asking whether you got to draw it like this or whether you can draw it like this, right?
Don't matter.
Well, usually, Steve, we draw it like this because this is then going to be this angle here that we can label BTH. It's usually reference to the horizontal. So in answering your question, you should probably do the horizontal first. Okay? Will the angle be the same? Yep. Just the opposite. Right?
Yeah.
Sample problem? I was a few.
What's up with the note on the bottom? Doesn't make sense.
The final velocity and the initial velocity, the final V and the initial V are both the same. 40. Right? That was this whole thing, Hannah. Will the final velocity be different from the original launch velocity? That's the whole big idea here. Okay, I just handed you a package. You now have 3 problem packages. Give me about 2 more minutes and then I'll be quiet. Okay? Your very first problem package was the one that looked like this. It had the cartoon guy falling off the roof. Okay? You have that package. You have answers. You have a QR code. As far as I know, there are all types of problems on there. I'm not really sure
You
actually.
didn't get a code.
Pardon me? For this one, I didn't give you a code? Oh, I think I made the code after. This is the one that I put the answers on Schoology, you're right. No QR code on your roof. The answers are out there, though, the solutions. Okay? The second package that you have is the one that looks like this. Thank you. Yep. Here. This one here, with the car driving off the cliff. You guys started solutions for me. I'm still working on it. I'm almost done. Okay? You do have answers on that. I discovered that when I did these, the first entire page is all the problems where cars are driving straight off cliffs. Okay? Then, I gave you this package just today. And I'm telling you well in advance, these are hard. These are hard. Don't do these until you've done these. Do some of these. Okay? I'm going to be asking you near the end of the week, show me a problem like this that you've done. Show me a problem like this that you've done. If you haven't done, how many problem types are there? 7. If you haven't done like 2 or 3 of each type, you're in trouble. You've gotta get started. You cannot do all those different problem types the night before the test. It's not gonna work. Get going. Okay? Find problems like that. You've got them. Some of them are relatively easy. The three hardest ones are these three that here.
Okay? The three hardest ones are this. Driving off a cliff, launching on level ground, projecting off a cliff. Will all of those be on the test? You betcha!
What are the other ones again?
The other ones?
What the other ones?
Yeah, the other ones are more almost grade 11, Zach. Straight up and down, off a cliff, dropped off a cliff, thrown down, and up and down, yeah. All of these ones are more sort of grade 11 gravitational field problems because they're not really two dimensions, right? They're just one dimension. So these four you should really be able to do. It's these three that are all in two dimensions. Okay? Do some problems. Get organized. That's what they said. I didn't say that.